Hi there. So now what we're going to talk about is some additional practice for us to get our inverses, composition of functions, and algebra of functions down. This comes out of chapter 10. You'll see that there's a section that in your homework that comes from chapter 10, and it says more of inverses and composition. Okay? But now that we've built up more functions, I think some extra practice would be really useful. Okay? So, let us suppose we have the following functions. Suppose I have f of x is 2x minus 5. G of x is x squared minus x. And h of x is x plus 2 over 3x minus 5. Okay? What I want us to do is let us practice doing a bunch of composition of functions, and let us also practice finding some inverses, and in a similar manner we'll then play around a bit with some algebra functions. Now, what do I mean by algebra functions? Adding, subtracting, multiplying, dividing. Okay? So, let's first start out with some composition of functions. Okay? First, let's find f of g of x. Okay? Remember, what you do is you work inside out. The first thing you do is you write what your function g of x is. In this case, g of x is defined to be x squared minus x. Now, what does it mean to compute f of x squared minus x? Everywhere where we see an x in our function f, we're going to plug in x squared minus x. In other words, I'll have 2. In place of x, I'm writing x squared minus x, and then I have the minus 5. So, when all is said and done, I can certainly distribute my 2, and that is my solution. Okay? Let me say this. Stop. Okay? So often then people want to set this equal to 0 and then use their quadratic formula to try to solve for x. No. In this case, all we wanted to do was the composition. Okay? Now let's go the other way. Let's look at g of f of x. This is going to be a little more work involved, but we can do it. Okay? What is f of x? It's, in this case, 2x minus 5. So what I'd like to do is compute g of 2x minus 5. What does it mean to compute this? It means everywhere where I see an x in my function g, I'm going to plug in 2x minus 5. Well, claim that's 2x minus 5 quantity squared minus 2x minus 5. Right? X squared minus x. Notice my parentheses. That's crucial. You're subtracting this whole quantity. Okay? If you didn't put parentheses, yeah, your sign on this 2x would be okay, but minus a negative, remember, is plus a positive. We'd run into problems here. So, let us now simplify this. Well, 2x minus 5 quantity squared means that we need to FOIL it. Okay, well, I have them written really close together, so remember, FOIL means first term, so 2x times 2x is 4x squared. Outside terms is minus 10x. Inside terms is minus another 10x. And then last terms is plus 25. I claim that's what you'd get if you multiplied this out. And now I'll also distribute the negative sign throughout my parentheses. So, now I combine like terms. I've got my 4x squared. Well, here I have minus 20x minus another 2x, so minus 22x plus 30. A little more work for sure because we had to FOIL out that term. Again, I know you can factor out a 2 and maybe do more, but stop. Okay? All All right, now let's compute h of f of x. What does it mean to compute h of f of x? Well, f of x here is 2x minus 5, so we're going to compute h of 2x minus 5. What does it mean to compute h of 2x minus 5? Everywhere where we see an x in our function h, we're going to plug in 2x minus 5. Okay, so in my numerator, in place of that x, I have 2x minus 5, and then I have plus 2. And in my denominator, I have 3 times 2x minus 5 minus 5. Notice, this was one place where there was an x in my function, so I plugged in 2x minus 5, and here is the other place. All right, well, we can certainly simplify this a bit. I claim we have 2x minus 3 in our numerator, negative 5 plus 2. I can distribute my 3, and I claim I'm going to get 6x minus 20. And there we have it. All right, now let us compute, let's do this. What if now I wanted us to compute f of x minus g of x? Well, key thing here, parentheses. F of x is 2x minus 5, and I want to subtract g of x, which is x squared minus x. Why are parentheses so crucial? Well, in the first term they're really not, but in the second term they are, because you have to remember you're subtracting that entire quantity, so you need to distribute your negative sign throughout your parentheses. So if I combine like terms and write these in descending order, I have a negative x squared, 2x plus 1x is 3x, and then minus 5. Okay, what if on the other hand, I want to take f times g? Can we compute that? So we've done a difference, and the way you add them is the same way. In fact, then you don't even have to worry about parentheses. Okay, so there's subtraction. Here's multiplication. Well, we're in luck. This isn't too bad. F of x is 2x minus 5, and we want to multiply that by g of x, which is x squared minus x. Why are we in luck? Because there's 2 terms in each, so really we can just FOIL this. Let's do it. First terms, you get 2x cubed. Outside terms, you get minus 2x squared. Inside terms, we get minus 5x squared. And last terms, we get plus 5x. Our last step will be to combine like terms, which is going to give us 2x cubed minus 7x squared plus 5x. All right, again, stop there. Okay? Now, what I want to look at here is what if we want to look at f of x divided by g of x? Fortunately, there's not a lot of work you have to do here. There is one thing you've got to deal with, and that's domain issues. Okay? Well, let me show you. F of x is 2x minus 5. G of x is x squared minus x. I claim we're done. Okay? This is it. Now, what I would like to mention to you, though, is the fact that we've got some restrictions here. Really, even over here, we've got some restrictions with our domain. Okay? Notice I didn't mention domain with f or with g because we have no restrictions. Remember, our domain issues come when you worry about dividing by 0 or taking the square root of a negative number. Don't have to worry about that here. Don't have to worry about that here. With h of x, we actually do have some domain issues. Do you agree 3x minus 5 equals 0 is a big no-no? Can't have a 0 down in your denominator. So let's see what value of x gives us this. First thing you do is move your 5 over, then divide by 3. So the way I would write my domain for h of x is x cannot be equal to 5/3. Implicit in that statement is all reals except 5/3. So while we're on the topic of our domain, what's our domain here? Well, in this case, I can't have x squared minus x equal to 0. So I'll ask myself, where does that happen? Well, I think the easiest way to look at this is to factor. We can certainly pull an x out and we're left with x minus 1. Now I have the product of two things equal to 0. So either the first one is 0 or the second one is 0. In other words, x equals 0 or x equals 1 are the two places that will give me a denominator of 0. So the way I would write my domain here is x can't be 0, nor can it be 1. All right, let's practice a little more with that. Okay, what if on the other hand, I want to look at this? Let's do two more of these guys. G over f. Well, again, this is pretty chill, but now x squared minus x goes in my numerator, and 2x minus 5 goes in my denominator. Do I have domain issues? You bet I do. Okay? I can't let my denominator be equal to 0, so I'm going to ask myself, hey, where is this equal to 0? Well, solve for x. X cannot be 5/2. Okay, one more of these divisions. These are the most involved, which is why I'm spending the most time on them. Okay, let us compute h over f. Well, h is x plus 2 over 3x minus 5, and then we're dividing that by 2x minus 5. All right, you can't have a fraction divided by a fraction or a fraction within a fraction, okay? That's just nasty looking, and it's really just not a polite way to write things, okay? Remember, when you're dealing with fractions, if you have a fraction divided by another fraction, well, remember, when you divide by a fraction, you multiply by the reciprocal, okay? So, the way I would rewrite this to make it presentable is I would take my numerator. Now I'm dividing it by 2x minus 5. Implicit in that is over 1. So if I'm dividing by this, I'm multiplying by 1 over 2x minus 5. So the way I would write that then is, well, when you multiply two fractions, you multiply your numerators and you multiply your denominators. And that's that as simplified as it can be. Now, I would leave my denominator in factored form. The reason why is if then I want to know my domain, well, I've already got it factored, okay? Why FOIL it if you're just going to want to factor it again, right? We want to know where is my denominator equal to 0. Well, again, the product of two things is equal to 0 if your first one is 0, but we've already solved that. Or if your second one is 0, but we've already solved that. So I claim x cannot be equal to those values. All right, given this example, or these examples, I have one more computation that I would like us to do. for right now. And then what I'm going to do is have a different set of functions up on the board. And in my different set of functions, I'm going to have an exponential function and a logarithmic function. Okay? But before we move on with that, there's one other thing that I really want to compute, and it just pertains to my function g. So I'm going to erase the whole board because we're going to need it. What I want us to do is compute something that looks like utter nonsense, but I assure you this is a really important thing in mathematics. Anyone who's going on to calculus, this is something that you're going to encounter, I promise. It's called the difference quotient. Okay? What I want us to do is compute g of x plus h minus g of x all over h. Now, if we look at this in its entirety, that is so overwhelming. I mean, h is h. We're okay there. G of x, well, we know what g of x is. Okay? But this g of x plus h, let's deal with that. I'm going to call this side work over here, and we're going to compute g of x plus h. Okay? Again, what does it mean to compute g of x plus h? Well, everywhere where we see an x in our function g, we're going to plug an x plus h. So, I see an x here, so I plugged in x plus h, and I see an x there, so I plugged in x plus h. Again, notice my parentheses. That's crucial. All right, we want to multiply this out. In other words, we need to multiply out x plus h quantity squared. Okay? If we do that, well, you multiply your first terms, x times x is x squared. You multiply your outside terms, so plus xh. Your inside terms, plus another xh. And your last terms, which is plus h squared. And then we can rewrite this second bit without parentheses. Unfortunately, there are no like terms to combine. So it looks like what we have is an utter mess. Okay? Let's go back now that we've done our side work and do this computation. First thing, we want g of x plus h. Isn't g of x plus h this whole mess over here? Okay, let's write it out. X squared, oh, excuse me, my bad. Xh plus xh is plus 2xh. Might as well simplify what we can. Plus h squared minus x minus h. That was my g of x plus h. Now, what do we want to do with that? We want to subtract g of x. Do we know what g of x is? You bet we do. It's x squared minus x. And we're going to put all of that over h. Woo! All right. Let us now rewrite our numerator after we distribute our negative sign throughout our parentheses and see where this goes. Well, I'll rewrite my whole first term, x squared plus 2xh plus h squared minus x minus h. Now I'll distribute my negative sign, so I'm going to get minus x squared, and again, minus a negative is plus a positive. And that whole thing is over h. Now this is the beautiful part. Look, my x squareds cancel, and my x's cancel. You got to celebrate things like this. Okay, so now let's ask ourselves, what are we left with in our numerator? Well, we still have a 2xh, we still have an h squared, and we still have that minus h, and we're still dividing by h. You have to admit, already, this looks a lot nicer. Now, I claim there's one more thing we can do. Okay, what can we do? Well, notice I have an h in every term of my numerator. Can't I pull out that h? And then I'm left with a 2x in my first term, an h in my second term, and a minus 1 in my third term. Why did I do that? Because now I can cancel these two h's. And I claim I'm left with 2x plus h minus 1. I know this looks like a lot, but again, when you do these problems, what you want to do is you want to break them up, do your side work first, and don't forget your parentheses. These types of things usually simplify pretty nicely. Things will cancel out in a really beautiful way. And again, I claim this is not just some silly math textbook problem. This has very real life applications. And we'll practice more with our next set of functions. All right, so our next example that we're going to do with this composition and inverses is the following. Let's now take f of x to be e to the 2x. Let's take g of x to be x squared. And how about h of x to be the natural log of x? All right, so let's practice doing some compositions here. For example, what if we want to compute f of g of x? Well, that is f of x squared, because that's how g of x is defined. So everywhere where we see an x in our function f, we're going to plug in x squared. So that gives us e to the 2x squared. All right, what if now I want to do, well, how about g of f of x? Well, now we're looking at g of e to the 2x. So everywhere where we see an x in our function g, we're going to plug in e to the 2x. So that's going to look like e to the 2x quantity squared. All right, we're not quite done. We just need to use a property of exponents. Remember, when you raise something to a power, raise to another power, you multiply your exponents. So this is e to the 4x. Okay, now let's do, how about f of h of x? So now we're going to look at f of the natural log of x. So we'll plug in the natural log of x in our function f. So that's e to the 2 log x. All right, now this is really cute, okay? We can simplify this. Remember how when you have an exponent, you can bring it down in front? Well, of course, you can do the reverse. So I can rewrite this as e to the natural log of x squared. Why did I do that? Because these guys are inverse functions. So this is just equal to x squared. Isn't that fun? And last but not least, with our composition here, let's do h of f of x. So now we're going to do h of e to the 2x power. So I plug that in for x, so I have the natural log of e to the 2x. And again, these guys are inverses, so they cancel each other out, and you're left with your exponent of 2x. Okay, so I wanted to do a few more examples, especially because we've built up a bigger cache of functions. And here you go. And that concludes the chapter 10, more of the composition, inverses, and algebra functions. All right.